Well, good morning, everyone. So, isimulan naman natin yung opportunity na mai-present natin sa team at through Engineer Jericho and Engineer Ella, ang ating na-design for Unitop Dumaguete. This will be an opportunity na pwede nating tignan, balik-balikan, because this will be tackling today about chilled water system design, both mechanical and electrical, being spearheaded by another our Engineer Jericho and Engineer Ella. So take it away, Sir Jericho.
Okay, so wait lang, nawala yung slide test eh. Okay. Good. Okay, good morning everyone. So I'm Engineer Jericho. We're here to discuss yung Dumaguete electrical design. Now, okay, before we start, gusto ko lang sabihin ng 3 things. Number 1, I think this is the first time that we will be tackling electrical comprehensively. So, as much as possible, gagawin ko in terms of explanation in layman's term, since dalawa lang kami sa office. Second, this will be the introductory to the Dumaguete project. So I will be cross-referencing then sa ginawa ni Ella for further understanding. And lastly, since design of sorry. So lastly, third is, since straightforward lang naman ang i-design and through the advantage of technology, I'll be actually explaining things na hindi lang sa electrical engineering field, but mostly in electronics and in programming. So, sige, let's start. So, Dumaguete electrical design. So, next slide. Okay, so before I explain the plan, you need to understand 3 things sa EE. Number 1 is voltage, number 2 is current, and number 3 is resistance. Now, sa plants kasi normally you actually place the voltage and the current. The voltage and the current are the fundamentals of an electrical plant. Now, in the Philippines, ang ginagamit natin voltage is actually 230. 230 single phase, 60 Hz system. Now, normally, meron mga tweak yan. Sometimes we reach 220 volts, sometimes 240, but the nominal voltage of the facilities is 230. So, pag pumunta ka sa labas, normally is either 230 volts yan or 380, depending on kung ano yung distribution company mo, whether it's Meralco, Beneco, etc. Now, so like I said a while ago, electrical engineering is much more a comprehensive and computative field. So mostly puro calculations ang ginagawa natin. Now, so in this case, alam naman natin yung Ohm's law, B is equal to IR. So yun lang yung dapat natin intindihan throughout this designing phase. Next, another thing is I need to explain properly yung difference between the real power and apparent power, mainly because sa ginagawa natin mga chiller, okay, may kita natin the power input is basically in kilowatts. Now, if we're gonna talk about in electrical engineering or in our field, or if we're gonna base it in our electrical plants, most of the plants in terms of power input are in kVA or kilovolt ampere, or in our technical term is the apparent power. Now, the apparent power is basically the combination of all powers involved in a single motor. Si sabi ko motor kasi we're in an HVAC company. So in this case, may real power. Ito yung binabayaran natin na kuryente sa Meralco or kung sa kayo nakatira. Ang reactive power, this is actually the power across in a capacitor, inductor, etc. Now, in every motor, for example, sa aircon natin, whether it's chilled water, chiller, or BRF, or even yung mga FCUs natin, meron sila mga capacitor. A capacitor basically has a reactive power. Normally, ano yung purpose niyan? In layman term, sasabihin ko na lang, it actually improves the real power. Okay? The better the real power, the better the efficiency of your system. Now, so I will not elaborate on this, pero mostly, I think si Vince makaintindi din dito. Most of the computations na ginagawa namin is based on trigonometry. Now, kahit yung mga tinuturo namin dito, sila Aram, sila Eric, pinapakita lang namin ng basic solutions for computing for wires, computing for breakers, etc. But in actual sense, in theoretical sense, most of the calculations are based on trigonometry, particularly mga log sign and cosine. Now, apparently, ang pinakamataas na power, by the way, is actually the S, or the apparent power. In layman's term, para mas naintindihan nyo, pag nakita kayo ng mga KBA, o BA, or MBA, yun ang highest power of a motor can buy. For example, pag meron ka nakikitang MBA versus MW or megawatt, mas mataas in terms of magnitude ang MBA kasi meron siyang kasamang reactive power. Likewise, ang MBA ay MW pala or megawatt, yun yung mga ginagamit natin for power dissipation. Okay, now, so the basic formula that you need to understand for power is just the voltage times amperes. Okay, so throughout the calculation, puro voltage times ampere lang ginagamit natin. Okay? Now, so, okay, so ginagawa natin is basically, ang gamit natin is Spillflex in our company. Now, normally, depending on the system, whether it's three-phase or single-phase, gumagamit pa rin talaga tayo ng wires. Okay? Now, ang wires basically is PH Ba't ako nawawala? Hello? Hello? Dinig na ka? Ayan.
Oo.
Ayun, so going back, okay, sorry, wala, natanggal ako sa phone. Okay, going back, in our company, sa Unitech, ginagamit natin is PHHN
Mm.
or the term thermoplastic high heat nylon coated wire. Normally, PHHN ginagamit natin ang pinakamaliit na wire na ginagamit natin is 3.5. Okay? Now, based on the Philippine Electrical Code, hindi tayo pwede bumaba ng 3.5 for power wires or cable wires. Kasi, normally, sa mga aircon, sa mga motors natin, meron mga tinatawag na starting current and inrush current. Which rather, pag nangyari yun, tumataas siya yung ampacity. Hence, mas sunog yung wire. Pag gumamit low and lower. Now, so dito sa picture color red, yellow, green, black, blue. Because ang tinatawag basically means face may na signal. Hello? No, no. Okay. So, naputol ako ulit. Okay. So, going back, pag single phase, ginagamit natin two kinds of wires. Ay two color coding lang. R and Y, or red and yellow. Pwede rin gumamit tayo ng blue. And for the ground is color green. Now, hindi ka pwede mag-same color. Okay, bawal yon sa Philippine Electrical Code, mainly because we're dealing with electricity, especially if you're dealing with high voltage or high current situations, baka ikasunod mo pa. So, it is better to have a different colors for wires for safety na rin ng workers natin. Now, next slide. Okay, so going to the plant itself, okay, this actually will now become E2. Sorry sir, hindi ko pa na-update based on our conversation yesterday. However, this will become now E2 or the load sched. E1, mga general loads natin. On the E2, basically, we're just gonna place all of the load sched or all of the load equipment that we're gonna use. Now, if you're gonna look at it on the left side, ito yung mga chillers natin. Okay, ACCH or the air-cooled chillers. Now, rule number one, when you're designing an electrical system, one breaker is equivalent to one motor. You cannot place two or more motors in one single breaker. Why? Because number one, meron tinatawag na, like I said a while ago, meron tinatawag na starting current at inrush current. Now, the reason why we're preventing inrush current and starting current is yun yung pinaka-max current that a system can omit. Now, ang ibig sabihin nun, pag pag gumana isang motor, kasi di mo kinompensate yung starter at inrush current. Actually, according nga sa PEC, 10 times the original current yung starting current eh. Pag hindi nyo kinompensate yon, the possibility of your breaker will highly trip siya. Most probably mag-trip siya. Hindi pa nagsisimula yung makina nyo, trip na agad yung breaker. Why? Kasi nga, hindi na-compensate yung starting at inrush current. Second, pag hindi nyo consideration yan, yung mga sinabi kong factors, pwede ikasunod yung wire nyo. That's the reason why, and I'll explain later, meron tayong multiplier, which is 1.75, the least. Okay? Meron din 2.5. Meron naman siyang table sa PEC and even in the National Electrical Code based on the US table for that kind of situation. Now, if you're gonna check on the left side, yung load scale natin, we have 8 chillers with 110 kilowatt. Now, hindi ko pa siya ginagawang KBA, pero based on the conversation with myself and Surfing, I think gagawin natin power factor is 0.9. Correct me if I'm wrong, Surfing. Pero if you're gonna convert it to KBA, i-divide nyo lang siya ng 0.9. Yun na yung KBA natin. Now, gonna base it on the load scale para makuha nyo yung 3-phase. Okay? You're just gonna base it in this form. Pag single phase, volt ampere divided by the volt is equal to the ampere. Basically, ano lang, unit cancellation lang siya. Now, since we're dealing with motors, especially with ACUs, i-divide nyo yung power sa voltage. And then, you're gonna multiply it to 1.75, the least. The least 1.75 protection multiplier. Why? Kasi itong 1.75 na to, kasama na yung mga different factors, yung derating factor, yung mga continuous load factor, yung overload factor, etc. According to the PEC, the Philippine Electrical Code 2017, the 1.75 minimum factor is your pinaka-minimum na multiply. Hindi ka na pwede bumaba dyan, pero pwede ka tumaas. At most is 2.5. Now, based din namin sa conversation with Sir Beng, ito na gagamitin natin multipliers. If your ampere trip is 50 ampere trip and below, your multiplier will be 1.75. Why? Kasi if gumamit ka ng 2 or 2.5, masyado naman over design tayo doon. Pag 50 ampere trip, pwede natin gumamit ng 2. Hindi naman siya masyado masama. And then, pag chillers, kasi normal chillers naman umabot ng more than 50 ampere trip, gumamit tayo ng 2.5 multiplier for the safety of the motor. Now, let me go back to this slide. If you're gonna look at it, nakita nyo may 3-phase column on the left. Now, nakita nyo is 166.98 amperes. Now, that 168.98 amperes is your current across the wires. Now, pag 3-phase, normally, tatlo yung wiring nyo. Line 1, line 2, line 3, with ground. Now, in some cases, may neutral line na tinatawag. Kaya if you're gonna look at the ACCH, 5 yung wires natin. So, when I say, for example, 311, ibig sabihin, it's already understood that line 1, line 2, line 3, neutral, and ground. Now, most of our chillers have a connection of Y delta. Ibig sabihin, Y connection yung from the source supply, delta yung load side, which is the chiller. Hence, kailangan natin ng neutral system. Okay? So, in this case, kaya nagkaroon tayo ng neutral wire, neutral bus bar. Ano pala yung purpose ng neutral? The purpose of neutral is to collect or to absorb unbalanced voltage or current system. Okay? Now, if I'm gonna continue the slide, for 3-phase calculation, volt amperes divided by volts times the square root of 3. Ang galing yung square root of 3 or 1.732, basically, the square root of 3 came from trigonometry. Hindi ko na i-derive yan, pero based yan sa PEC as well. Okay, 1.732. So basically, for motor loads, power, or the apparent power, volt ampere, divided by volts times square root of 3 is equal to the motor load times the protection multiplier for our system. Now, laging square root of 3, hindi pwedeng square root of 2, hindi pwedeng square root of 4, hindi pwedeng ganun. Laging square root of 3 siya. Okay? Now, by the way, the reason bakit square root of 3 is because 3-phase siya. So, pag sinabi sa inyo, 3-phase supply ka or 3-phase yung gagamitin yung motor, automatically that may 1.732 tayo sa denominator in solving current. Now, ito yung sinasabi ko. This is based on the National Electrical Code, a US-based criteria kung ano yung protection multiplier natin. Now, if you're gonna look at it, 1.75 yung ginagamit natin dito sa Unitech. The most is 2.5. Now, most of the time, current multipliers is between 1.75 2.5 lang. Hindi siya tataas in that range. Now, if you're gonna multiply it within that range, okay na yung system yun. Hindi na siya mag-flip, hindi na an electrical system, always remember, mas taas yung ampacity dapat ng wire nyo kaysa sa breaker nyo. Why? The reason, pag mas mataas yung breaker nyo versus sa ampacity ng wire ninyo, the tendency is sunog na yung wire panigit yung breaker. So in this case, dapat you need to be cautious when you're designing wire ampacities kasi baka ganun naman wire nyo, hindi pa nagtitrip ng breaker. Hindi wala, para saan pa yung protection device nyo. Okay? Now, ang gamit natin circuit Unitech is actually miniature. It's a case-to-case basis. But most correct, if based sa tama sa internet, I think this is 500 ampere trip Schneider breaker. Now, the next slide shows you the ampacity table. Now, ang gamit natin is THHN. Now, if masyadong blurry yung yung picture, I apologize for that. But ang gamit natin is copper at 90 degrees. Okay? So, yun. Sorry, nawala ulit ako. Okay. The left side is in AWG, also known as American wire gauge. Now, may kita mo yung mga sizes, 18, 14, 12, 10, 8, 4. Okay. Sa Philippines, alam lang nila is 12 at 14. Ang 12 sa English system is actually 3.5. 3.5 square mm squared, while the 10 is 5.5 and so on and so forth. If you want to get the actual metric measurements, meron naman akong table dito sa desk ko. Now, when you choose a wire, you need to understand na dapat mas mataas yung ampacity niya ng wire versus the breaker itself. Like I said a while ago, pag hindi nyo ginawa yun, sunod na yung wire nyo, hindi pa nag-trip yung breaker. Now, each wire has its own ampacity. Ampacity is the combination of two words, ampere, capacity. So, ampacity yun. Um, if you're gonna check the table, merong list of ampacities na kailangan nyo involve. For example, pag umabot ka ng 35 amperes, dapat yung wiring nyo is size 10. In AWG or in corresponding metric system, 5.5. Okay? So, ganun ganun yung basis mo in choosing a wire. Now, take note, pag single phase yung wire ninyo, dalawa yung wire nyo for hot wires. So, in this case, dalawa yung wire natin for 5.5. While the grounding, normally, okay, dapat ang grounding nyo, hindi dapat mas taas sa hard wire or sa live wire na gagamitin niyo. So, like I said a while ago, 5.5 yung hot wire natin, dapat mas maliit siya sa 3.5 or 2.0. Now, by the way, speaking of 2.0, most of the commercial establishments in the Philippines don't use 2.0. Walang gumagamit sa 2.0 na wire. Normally, ginagamit na natin 2.0 na wire is for communications or sa bahay. For actually ngayon, hindi na nga 2.0 ginagamit sa bahay for wires. Pero in this case, sa Dumaguete, pumayag naman na gumamit tayo ng 2.0 mm squared for grounding. Okay? Now, so next slide. Okay, now for the sizing of the breaker, this is actually a standard breaker, standard standard table for breakers. Now, the lowest na meron tayo sa Philippines is actually 10, hindi 15. Pero as much as possible, we're avoiding using 10 ampere trips. Why? Kasi for economic reasons. What if kasi for expansion naglagay ka ng isa pang load? Baka sumobra na ng 10 amperes. Okay? Now, the lowest dito sa Unitech is 20 ampere trip. For the reasons why, for the plans, para hindi tayo masyadong anin ng munisipyo. Kasi hindi pumapayag ng munisipyo na less than 15 ampere trip. Now, sa Dumaguete, we use 500 ampere trip for the ACCH or air-cooled chiller. While I think for the pumps, gamit ko ata is 175 ampere trip breaker. So, conduits. Now, if we're gonna check the load scale a while ago, meron tayong, balikan na natin. If we're gonna check the load scale a while ago, meron ditong unit number or basically kung ano yung description ng loading mo. For example, at in this case, chiller. Paminsan, pwede tayo gumamit ng ilaw, pwede tayo gumamit ng, alam mo yun, anong klaseng load, rep, etc. Next is the voltage. Yun yung format. May voltage, whether it's 380, 400, 230, or 220. Depende na lang talaga sa system na binigay ng Meralco, etc. Power input, ito yung kinukuha ninyo sa mga terminals nyo or sa chiller handouts natin. Of course, the current column. And then, the protection device, the ampere trip, yung sinasabi ko kanina, the circuit breakers. Ampere frame, by the way, ampere frame is basically, in layman's term, the maximum allowable current protection sa casing ninyo. Kasi most of the casings that we have is based on NEMA classification or the National Electrical Manufacturers Association rating. Now, sa Unitech, ginagamit natin is NEMA 1, NEMA 3R, and NEMA 12, depending on the situation. NEMA 1 is basically, ideally, ginagamit natin for FCUs. NEMA 3R, normally, NEMA 3R tsaka NEMA 12, ginagamit natin siya for MCCs. Ang difference kasi nga, NEMA 3R, NEMA 12, as far as I know, and based on sa experience ko, NEMA 3R is waterproof. NEMA 12, waterproof din siya, weatherproof siya, weatherproof. It can sustain a high temperature system, ambient temperature. It can sustain actually snow, weather, in mga different kinds of weather conditions. It can actually sustain. Okay, ito yung wires kanina, sinasabi ko, ina-elaborate ko kanina, pag depende yan sa connection, pero in this case, ang mga pumps natin is wide delta, so may neutral line tayo dito. And then the conduits. Okay, sa conduits naman, marami tayong ginagamit na conduits dito. Like I said, marami. Pwedeng PVC, pwedeng EMT, pwedeng IMC. Or in some cases, gumagamit tayo ng flexible or liquid flexible, liquid tight flexible. Okay, for PVC or the polyvinyl chloride, yun ang pinakamura na conduit kasi it's made up from a polymer. Now, normally ginagamit natin PVC for residential, for residential area, or kung may kailangan ka ibaon sa lupa. Okay. Next, RSC or the rigid steel conduit. Okay, ang rigid steel conduit ginagamit natin dyan paglabas. Kasi nilabas talaga ng bahay. Rigid steel conduit. Ang rigid steel conduit, ginagamit natin yan sa labas. Normally, ginagamit sa mga service entrance, sa mga meter center, etc. Next is EMT or the electric metallic tubing. Ang EMT kasi, maganda siya tingnan for open ceiling. Okay? pag open ceiling design, ginagamit natin EMP or IMC. The big difference lang between the two is EMP is lightweight. Madali siya masira. Kaya nga pwede siya i-bend without using an elbow. Eh. Pwede ka mag-bend ng EMP. Whereas in IMC, it is galvanized iron. Meaning, meron siyang high melting point, meron siyang high electrical conductivity. Meaning, pag IMC, nga, mabigat, mas mahal, pero pag meron ka naman ceiling na meron nag-welding or meron kailangan na coring, matibay siya at pwede natin siyang gamitin. Now, normally sa mga sealers natin, ginagamit din natin is liquid type na conduit. Liquid type conduit basically is a flexible conduit na may plastic na coating para hindi pumasok yung tubig. The real purpose lang bakit tayo nagko-conduit is because is to prevent water inside the wires. Kasi pag nabasa yung wires nyo, masisira insulation nyo, pwede magkaroon ng arcing, electrical arcing. Pag nagkaroon ng electrical arcing, pwede kang masusunog yung system nyo. Doon pumapasok yung tinatawag natin na short circuit na fire. So, in measuring or kung ilan yung wires na kasya per conduit, meron tayong table na ginagamit. Okay. Yung table na ginagamit natin, you can actually see it sa EEC. If you want to know kung paano tayo mag-size ng PVC, you can actually get the table from me. Pero in the actuality, hindi siya katulad ng sealed water na ilan yung TR for example, sa drain, ilan yung TR corresponds to this size of PVC. Hindi siya ganun sa electrical. Ang pinag-uusapan lang natin sa electrical is the number of wires na pwede ikasya. Why? Kasi when you place a wire in a conduit, nagkakaroon siya ng derating, umiinit siya sa loob. Kaya may tinatawag na derating factor. Now, as you can see the tables na may EMP, IMC, or RMC, the rigid metal conduit, yung sinabi ko kanina. You can see based sa American wire gauge, 4 of 10, 8, yun yung mga sizes ng wire sa taas. And the numbers on the screen that you can see, yun yung the number of wires that is allowable sa loob ng wire mo or kasya sa loob ng conduit mo. Now, pwede ba sumobra? The answer is yes. Pero the tendency is masyadong masikip, and that pag masyadong masikip ang wires mo sa loob, the tendency is baka mag-short naman siya. So, iniiwasan natin siya if possible. So next, this is A3. Basically, this is just the MCC design. Like I said a while ago, all of our breakers are enclosed in a panel board made from NEMAT 3R. Okay? Now, in each MCC, meron tayong disconnection switch and individual breakers. The disconnection switch para lang for protection purposes. Now, if we're gonna look at it, nakasulad dyan yung ampere trip, ampere frame, the voltage 380, and then meron nakikita ang 3P dyan dito sa mga MCCs natin. Ang 3P basically means 3-pole. Pag 3-phase kasi 3-pole, pag single phase 2-pole. Ang ibig sabihin ng pole in layman's term, yun yung papasukan na wire. Kasi pag single phase, dalawa lang yung wire na gagamitin mo, kaya 2-pole. Pag 3-phase, tatlo yung wire na gagamitin mo for line, kaya 3-pole. So, yun. Okay, and then individually, each motor, yung chilled water pump natin, meron siyang Y delta and BFD starter. Now, the question is, can Y delta stand alone without a BFD? The answer is yes. A Y delta is a soft starter. Okay, it actually helps in reducing the inrush current and the starting current. Okay, like I said a while ago, earlier, ang starting current is 10 times the normal current rating. Now, with the help of a Y delta, the starter, and the BFD, it actually limits your starting current, meaning it actually prevents a high power usage. Second, it actually helps in stabilizing the voltage. Kasi take note, the longer the wire that you use, mas malaki yung voltage drop. Kasi pag mas malaki yung voltage drop mo, liliit yung voltage na ginagamit ninyo. Hence, pwede magkaroon ng fluctuation. Pag nagkaroon ka ng fluctuation, pwede masunog yung system mo. Now, other things to say about here. Nakasulat lang dito yung feeder line natin from the MCCs. Yung individual wires natin dito sa chilled water pump. And in-elaborate lang natin yung mga wires na gagamitin natin for individual motors natin, sa chillers natin, sa ventilation sa FCU and sa smoke evac. Okay? Next, again, BFD versus soft starter. Like I said a while ago, um, we don't necessarily need the BFD in order for the system to work kasi may Y delta na tayo. But the real purpose why we use BFD is number one, aside from altering and controlling the frequency. Kasi yung frequency, meron din siya corresponding effect yan sa sa temperature difference. It is adjust yung speed niyo, hence, pwede adjust yung frequency niyo, pwede ma-adjust tuloy yung speed correspondingly. Okay? So, ito yung ginagamit natin, BFD, on the left side. Nakuha ko lang ito sa internet, pero ang ginagamit natin is normally done pause, if correct me if I'm wrong. And then on the right side is actually a DPS, or the differential pressure sensor, which I will be elaborating later. Okay, so yung mga single line diagram ng mga BFD natin. Now, from the BFD, one is to one ng BFD natin. One BFD, one pump. Okay? In Dumaguete, sa Dumaguete, ang meron tayong reserve BFD. Why? Kasi ang reserve BFD para siya for reserve nga lang. Ginagamit natin for reserve purposes. Pag may maintenance yung isang BFD or isang pump, pwede natin gamitin yung the last BFD for that system. Okay? Next, nilagay ko lang dito yung logic sequence. The purpose of the logic sequence is para madaling i-program kung sino yung magpo-program ng BFDs natin. Okay, next is the controller system. Ang controls natin for ECU can either be remote control, ang ginagamit natin sa office, and centralized controller. But I decided to use a centralized controller sa Dumaguete. Now, this is actually the FCU controller layout. Individually, I divided into many zones. I think 16 nata suit natin. Now, each zone is home run sa EEROM. Kasi doon ko nilagay yung control panel natin. Now, so if you're gonna look at this, different zone corresponds to different number of FCUs. Now, by the way, the max number of controllers, the max number of FCUs in a single controller is 16. So, ang hatian nito sa 16 FCUs. Now, this is actually the riser diagram for the FCU layout. Now, I placed the controller room, hindi pala sa E-room, sorry. Nilagay ko pala siya sa office, yung controller room. Why? Kasi para madali natin siya i-control. Now, since we're talking about centralized air conditioning, kasi nandito yung controller niya, naglagay ako ng RS485 module, communication module. The RS485 is actually a connection wire that brings through a multiplexer system. Pag sinabi ko multiplexer system, basically, from a single frequency unit, it will actually divide to many frequencies. In this type of scenario, the main source of information comes from dito sa communication module natin, dito sa CPU natin. Okay? Now, through the process of multiplexing, um, sinegregate ko yung information for each FCUs divided to different zones. So in this case, kung 16 yung controllers natin, 16 different hatian ng frequencies for that information to occur. Now, sa madaling salita, para magkaroon siya
Naputol si Jericho.
Ay, sir. Thank you, sir. Yun. Aircon muna sa nilagay ko.
Okay, thank you very much na i-present ng ating kasama dito sa M.E.Forum, si Engineer Jericho. And tuloy naman natin kay Engineer Ella para i-share sa atin yung design ng chilled water system for mechanical works.